only lobes I've got done with like a needle.
Okay, guys. All right, number 16. Rewrite each series using sigma notation in both terms of both T0 and T1. So I'm going to make two sigmas. And the first thing after I make my two sigmas, I'm going to count how many terms. 1, 2, 3, 4, 5, 6, 7 terms. Oh, just like, I don't know, 7 tentacles. Anyway, so on both of my sigmas, I'm going to go from 1 to 7. Everybody good so far? So I drew two sigmas and I counted the terms. Okay, now I'm going to decide if it's arithmetic or geometric. It looks arithmetic to me, and it looks like it's going up 2 each time. And that term 0 is 601. How do you feel about that? Going up 2 each time, and term 0 is 601. Everybody good? Okay, so the term 0 equation is going to be 2n plus 601. And the term 1 equation, you still start with 2. You bring n down a notch and then balance it out with using term 1 instead. And that's it. Any questions about number 16 before we move on? Super important. Okay, now we're going to do number 19. Move down to number 19. Number 19 is like the one that you guys had on your quiz where you had to find the number of terms with quad formula. However, it's set up a little different. It's set up with sigma notation instead of giving you the series. And so I'm going to rewrite it to make it look like we're used to seeing it. Do you guys know how I could find term 1 from this business? Plug in 1. Okay, so term 1 is 3 times 1 minus 1, which is 2. Does that make sense so far? Okay, now I'm going to find term 2, which would be 3 times 2 minus 1, which is 6 minus 1 is 5. Everybody okay there? Okay, what I'm going to do is I'm going to use this information to make a picture of the series. So it starts at 2, goes to 5, goes to 8, goes to stuff. And the sum is 1365. Okay. Hold on. I want to leave room. Okay. Now I'm going to do something kind of redundant, but I want you to see what I'm doing. So this is 3, going up 3 each time. Term 0 is -1. So T of n equals 3n minus 1. Why did I not really need to do that? Why is that kind of an unnecessary step? Colin, already in the problem. But do they always give it to you? No. Did I give it to you on the quiz? No, I did not give it to you on the quiz. So I want to make sure that you saw how I got it. I got it by finding the growth and then going back a spot. Okay, sum equals n over 2 first term plus last term. Okay, what is the sum? 1365. N is what we're solving for. And what's the first term? 2. And what's T of n? 3n minus 1. Okay, then I combine those two constants together. 2 minus 1 is positive 1, so I got 3n plus 1. Times 2 on both sides to get rid of the denominator. And one of the things I noticed when I was grading the quiz is a lot of people were doubling this also. You don't double this part, you just double this side. And the 2 and the 2 cross out over here. 2 times 1365 is something. Okay. N equals negative b plus or minus square root b squared minus 4a c all over 2a. And this is kind of that moment of truth moment right now. I'm going to type this square root part, and if it doesn't come out evenly, I did something wrong. Yay. And remember, on these, n has to be a positive whole number, so I only have to do the plus part. So negative 1 plus 181, enter, is 30. Right. The first thing we're doing today is a resource page in your packet. And it has a big table at the top. It says like problem 151 or something. No, it does not. It says 10.3.2. Okay. For number 151, our goal is to fill in this table. And this column is the total number of objects that you have. This is the number that you're choosing out of that total number of objects. And we're going to calculate the combination. And remember, combination means groups. So the order does not matter. Now, interestingly enough, I probably didn't show you this because I didn't want to, but if you have 0 objects and you choose 0 of those objects, the answer is 1. There's apparently one way to have 0 objects and choose 0 objects. I don't know how that works necessarily. Also, if you have 1 object, it looks like there's one way to choose 0 objects out of it. And if you have 1 object, it looks like there's one way to choose 1 object. Okay, so that means if I have 1 pen, how many different groups can I make out of my 1 pen? What? That's the first time that these actually make sense. Okay, now why is there nothing here? This is saying if you have 0 pens, how many different ways can you arrange 1 pen? That's not possible. So the total number always needs to be bigger. We will not be filling in the rest of these boxes. Okay, let's go to this line. This is saying I have 2 pens. How many different ways can I arrange 0 of them? Apparently that's 1. I feel like that's kind of a theoretical answer, but that's okay. If I have 2 pens, how many different ways can I arrange 1 pen? 2 different ways. If I have 2 pens, how many ways can I pick 2 pens? 1 way. Okay, do you need to know that moving on? Not really. What you need to do is be able to pick up on patterns. Looking at the pattern, what do you think the rest of the answers are going to be in the choose 0 column? 1, great. Mathematical pattern deduction. That is one of the things that we try to teach you. Okay, next. Going down the diagonal right here, what do you think the rest of these boxes are going to be? 1, great. Okay, next easy pattern. What do you think this box is going to be? 4. And what's this box going to be? 5, 6, 7, 8. And that should make sense if you think about it. If you have 8 pens, how many groups of 1 pen can you make? 8 groups. Okay, now look at the diagonal again. What should this box be? 4, 5, 6, 7, 8. Okay, now more advanced pattern. What should this box be? It's not 9. 10. It's going up 2, up 3, up 4, up 5, up 6, up 7. Okay, now look down this diagonal, 1, 3, 6. What should this box be? 10. Anybody? 15. 21. 28. Okay. We only have a few more to fill in. Okay. Now this is a really, really challenging pattern detection. This is going up 3 and this is going up 6. So how much will it go up next? 10. It's following these numbers over here. And I'm going to teach you an easier way to do this in just a few minutes. What is 35 plus 21? 46? 56? Okay, so then we can say this box is okay. So what's the last one going to be? 70. Wow. That was a really fun puzzle for the morning. This is something called Pascal's triangle. And you're going to use Pascal's triangle through the rest of algebra. And I'm going to teach you an easier way to make it now. That way it's totally great. And you might be wondering why you're not doing it on the calculator. You could. But the way I'm going to teach you in the triangle below is how we're going to actually display it for the rest of Math 3. So we're not going to display it to look like this. We're going to display it like this. This is called Pascal's triangle. And we need to do some labeling. So this is row 0. Row 0 is this one right here, corresponds to this one right here. Okay, this is row 1. Row 2. Row 3. Row 4. Row 5. Row 6. Row 7. We didn't go all the way to 8 on this picture. Can you guys see that these two ones right here correspond to these two ones right here? And that this 1, 2, 1 corresponds to this 1, 2, 1 right here. Okay, so now I'm going to teach you how to do this much easier. Every row starts with a 1. Every row ends with a 1. And what you do to get the next spot is you add the 2 boxes above it. So 1 plus 2 is 3. 2 plus 1 is 3. So much easier than the pattern detection we were trying to do. I mean, what we did was cool, but like this is way easier. Okay, so 1. What would this be? 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And it ends with a 1. And you might ask yourself, Mrs. Talbot, is it symmetric? And the answer is yes. So if you figure out this box will automatically match. You could draw a line of symmetry down the middle of the triangle. It has to match on both sides. Okay, row 5. 1. What is it? 5, 10, 10, 5, what? Row 6. 1, 6, 15, 20, 15, 6, 1. Look back up at your table. Does that match row 6 in the table we did at the top of the page? 1, 6, 15, 20, 15, 6, 1. Hello? Okay, you guys fill out row 7. 1, 7, 21, 35, 35, 21, 7, 1. And as fascinating as that is, I need to teach you why that, what do we use it for? It's great. It's awesome. Super fun. Also a great parlor trick. You know, if you want to break the ice with somebody at a party, you just be like, hey, you want me to show you Pascal's triangle from scratch? You know, that's the way to get in with all the cool kids. I'm glad at least one person finds me slightly funny. Or is it listening at all? Okay. So I want you guys to look at the back of the page. And Miss Rice and I gave you a page of what you might see if you Google Pascal's triangle. These are all representations of Pascal's triangle. These are all saying the same thing. This is the same thing as this. Excuse me. Which is the same thing as this. Which is the same thing as this. The one on the middle row right there with the big parentheses, that's how we write it in AP Stats. So in AP Stats, we do a probability chapter with combination, and you write it like that. And this says, 4 combination 0, 4 combination 1. It's not a big deal. It's just big parentheses. What? That isn't what? Hard to take me seriously? Mr. Hanks wanted to come to school. And then at the bottom is actually what we're going to use it for, which is binomial expansion. So I'm going to show you a way to multiply all of these things out without using boxes. It's much, much faster than boxes by using Pascal's triangle. So that's the whole point of this. So if you guys could not put this far away, just scooch it aside. And now we're actually going to apply our math. Oh, good. Okay, so for this first one, I'm just gonna do CPM style to start because I need to prove to you that what I'm teaching you actually works and it's not some like hokey stuff I just made up this weekend to trick you with. Can you imagine? Could you imagine if there was somebody like a teacher, like a math teacher that just like made up their own stuff and like taught you all the wrong things and like made up their tests and then you went to the real world and it was like all wrong? Or like they made up their own PEMDAS or something. Can you imagine? I don't have like the creativity for that, but man, that'd be a way to go out. Like if you're gonna retire, I don't know. Anyway, just saying. Okay, so just pretending you're in math one, adorable little math one student, like a plus b squared. Okay, Mrs. Talbot's gonna want me to make a box. And she's gonna want me to make a box with the same thing on the top as it has on the side, because that represents a plus b times a plus b. A squared, a times b, a times b, b squared. And Mrs. Talbot would say, combine like terms. So this would be a squared and two ab's and b squared. And you're in math one class and you drop the mic and you walk away. You're very excited about doing your box for a plus b, a plus b. Okay, but what I want you to notice, because we're working on Pascal's triangle, that there are coefficients that we do not write when we're in math one and not really thinking about this. There are coefficients in front of the a squared and b squared, and when there's nothing there, those coefficients are 1. And I want you to look at these numbers, 1, 2, 1, and tell me where you've seen those before. Pascal's triangle and which row? Row 2. It is the third row, but it starts with row 0. If you have labeled that, you would see that the top is row 0. And the 1, 2, 1 is on row 2. Now, if I was a math 3 student that was much more analytical, where could I get that 2 from the original problem? Yep. So row 2. So my goal is to teach you how to get from here to here without the box. And you're like, great, I don't really care when it's squared. That's true. You're not going to really care when it's squared, but when it's to the 6th power, you're going to care. Okay, now B, we're going to take this and take it one more step. So this time I have a plus b, a plus b, a plus b. Okay, now I hope that most of you can tell that if I multiply the first two, I would get the answer from my previous problem. So I could go like this, a squared plus 2ab plus b squared. That's just my answer from doing 2 of them. And multiply that times the third one. And this would require a 3 by 2 box. And remember, I just kind of cheated because I already had the answer from the previous thing right there. So a cubed, this would be 2a squared b, ab squared. I'm always going to write the a's in front and the b's after, just alphabetical order style. A squared b, 2ab squared, b cubed. Combine like terms, I have a cubed, 3a squared b's, 3ab squareds, and 1b cubed. Okay. What do you notice about the coefficients? 1, 3, 3, 1. Where could I get those from? Row 3. And how could I have figured out that I was working in row 3 from the original problem? Exponent. Okay, now I'm going to abandon ship on the boxes. I've gotten to the 4th power. I really don't want to do a 4x2 box. And just imagine that you got this problem on your quiz, which is on the block day. How could you do this without boxes? And I'm going to tell you that you can use boxes on your quiz. If you hate this, box away. By all means, I don't care. I'm not going to do it, but you could. If you hated this, you could. Okay, so my next goal is to teach you how to get from here to here without any of this stuff in the middle. Okay, are you ready? A plus B to the 4th. What row am I in? Row 4. Okay, find your Pascal's triangle and find row 4. Now, if you're on the quiz, you don't have Pascal's triangle in front of you. So this is what you'd have to do. You'd have to go 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. You'd have to do that off to the side with adding. Okay, how many terms are there in row 4? 5 terms. And the numbers in row 4 are 1, 4, 6, 4, 1. Okay, are you ready? Okay, look at the first number in Pascal's triangle, and that goes in the front. Okay, now, are you guys okay if I call this the front seat and this the back seat? Can you guys all imagine that this is a little car and this guy's in the front seat and this guy's in the back seat and this is the spoiler for anybody who likes cars? Ha ha ha, that's my car joke of the day. Okay, do you guys understand? Front seat, back seat. Okay, so what you do is you take the front seat thing to the full power of the problem. Add the back seat thing to the 0. Plus. Okay, now I go to the next number in the row. The next number is 4. Pay very close attention because if I'm going to lose you, it's going to be right here. You take the front seat and you go down a power. And you take the back seat and go up a power. So this is the A is going to go 4, 3, 2, 1, 0. And the B is going to go 0, 1, 2, 3, 4. Because these have to add up to 4 each time. 4 plus 0, 3 plus 1. Okay. Next one. Next number is 6. Front seat down. Back seat up. Four. Front seat down. Back seat up. Plus 1. Front seat down. Back seat up. Okay, and then what you do is you clean it up. So you don't write the 1. B to the 0 is 1. So those just cancel out and you have A to the 4th. You don't write the 1 exponent. So this is 4A to the 3rd B. Plus 6A squared B squared. Now I'm here. 4A B to the 3rd. Don't write the 1. Don't write the 1. B to the 4th. Okay, we have one more problem. And I want you to imagine how many boxes you would have to do for A plus B to the 6th. Can you guys imagine how many boxes that would be? This is worth learning to save you time and money on your car insurance. Oh, wait, no, that's the gecko, not this. Okay, last problem of the day. And then I want to tell you what your quiz topics are. Row 6. How many terms do you think row 6 is going to have in it? 7 terms, just like 7 tentacles. Okay, how do I go to row 6 by heart? So I'm going to go 1, 1, 1, 1, 2, 1. Now I understand you have it next to you on your resource page. I just want to practice making it so that you guys can always make it. 1, 3, 3, 1. 1, 4, 6, 4, 1. 1, 5, 10, 10, 5, 1. 1, 6, 15, 20, 15, 6, 1. Do you understand how to make the triangle? Are you thrilled about it? Maybe not. Okay. Now I'm going to start down here because I know this is going to go long. First number in row 6 is 1. Okay, what is in the front seat? A. A to the full power of the problem. Full power. B to the 0. plus. Okay. What number is next? 6. A goes down a power. B goes up a power. Do you see how the exponents always add to 6? It's really helpful. 15. A down. B up. I'm not even halfway. I should have started way over here. 20. A down. B up. 15. A down. B up. And you see how once you get to the other side, these are just like reflections of each other? You see what I mean? Like this one's 4, 2, and this one's 2, 4. Oh man, I got it in there. Okay, so now I clean it up. That's a 1, that's a 1, that's a 1, that's a 1. A to the 6. And for my visual people, it might help your brain to put these in little bins so that it doesn't all get squished together. Okay, so A to the 6th plus 6, A to the 5th, B to the 1st, we just write B, plus 15, A to the 4th, B squared, plus 20, A to the 3rd, B to the 3rd, plus 15, A squared, B to the 4th, plus 6, A, B to the 5th, plus B to the 6th. I know that's tedious, but I want you to imagine what it would look like if you did boxes up to the 6th power. This is highly superior. Now, again, if you hate this and want to do boxes, that's on you, totally fine. Not going to mark it wrong. I just think this is worth figuring out because it saves you so much time. Okay, can you guys flip to the quiz review, please? Okay. This is the homework. There's 8 problems. I'm a little concerned with your ability to do 7 and 8 on your own tonight because we only did A plus B, and these ones have other thingies in them. So let me just help you start number 7. But do you guys know what the directions are mean for this? What does evaluate each geometric series described to mean? Find the sum. So that just means use the sum formula for geometric. These ones should not be too hard. Remember though, if there's no number in front, this is a 1. So put a little 1 times in the front of that so that it looks like this guy. Okay. Do you guys know what this is? Infinite geometric series. Yeah, it's just the sum, but it's first term over 1 minus r only. If you need to, you can look at problem 10-116. That's where the notes are for that. Okay, now this, number 7. Let me just set this up with you. So, do you guys see that it's row 4? Everybody see that it's row 4? Okay, that's good. And then for row 4, it's 1, 4, 6, 4, 1. Do you guys know where I got those numbers from? Okay, so you start with the 1, and then do you remember how I said you do the front seat thing to the full power? Do you guys remember that? Okay, the front seat thing in this problem is 3b, and you have to put it in parentheses and put it to the 4th. That means the 3 also goes to the 4th power. And then in this problem, the back seat thing is -1 to the 0. Do you guys see what I mean by -1? Plus 4, front seat down a power, back seat up a power. Okay, I'm going to let you guys finish that, but I want you to know that this is 81b to the 4th right here. Can you guys tell that that is 81b to the 4th? Do you know where I got 81 from? 3 to the 4th power. So you kind of have to like distribute it, like what I mean. Okay, I'm gonna let you work on that. I can help you with it tomorrow, because we're doing a lot more of this tomorrow with other things in there other than just A and B. So we'll clear all of that up. Do you guys have any idea what your test topics are, your quiz topics from this sheet here? There's 3 questions. One of them is evaluate a geometric series. And the formulas will be at the top again. Do you know what the second question is? Evaluate an infinite geometric series. Do you know what the third question is? Expand a binomial. And again, if you panic on your quiz and want to use boxes, it's fine. But I really think it's worth figuring this out just to save you in the future. Yes. Yes. Yes, calculator, no notes, but the series formulas are at the top. You will have to make your own Pascal's triangle though if you want that. Alrighty-o. Okay. Give this a go.